Let's show the division law of exponents, or also known as the quotient rule, given with the expression a to the power of m over a to the power of n is equal to a raised to the power of m minus n. To do this, of course, let's start with the idea that a here, and our entire expression, is what we call as our base. And of course, m and n are our exponents. This tells us that if we are going to divide expressions of the same base, we simply copy that base and subtract the exponents. So let's show that this is really true using this given expression. Let's say that a to the power of m in expanded form is equal to a times a times a times dot 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 a, where there are m number of a's. Okay, this is its expanded form. And let's also say that a to the power of n is also a times a times a times dot 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 times a, where there are n number of a's. We know that exponentiation is a shorter way of writing a very long expression of a product of the same base or coefficient. So let's try to use this representation and see after the given expression here will return to this. Let's have a to the power of m over a to the power of n. So this is equal to, using the expressions here, a times a times a times dot 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 a, where there are m of them, over a times a times a times dot 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 a, where there are n number of them. Now, there are two possible ways here, but let's try to use the general discussion where m is greater than n. In short, the number of a's on our numerator is more than the number of a's that can be found on our denominator. In short, if we're going to use the cancellation law here, where we could cancel this by pair, something like that, cancel here, we would reach a certain amount of number of a where we could cancel all the a's that can be found on our denominator. Take note that m is greater than n here. So what does this tell us now? There are still number of a's that are left on our numerator. And how many number of a's are there? That would be given as the number of a's that can be that is actually remaining on our numerator is where we subtract m by n, because when we use the cancellation law, we have removed n number of a's from our m. In short, we could say that the number of a's remaining here, if there are actually m minus n number of a. This is why you will have here a m minus n. So this is the proof why a to the power of m to be divided by a to the power of n is equal to the a raised to the difference of their exponents. Now, another situation is, of course, if m is less than n. Since m is less than n, let me rewrite it here, this expression, a to the power of m over a to the power of n. You have a times a times a times dot 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 times a, where there are m of them, over our denominator a times a times dot dot dot, where there are n of them. Once you use the cancellation law, all number of a's on our numerator will have a pair on our denominator, meaning there would be no more a's that can be found in our numerator, but there will be items on our denominator. This is still true by the subtraction, where we subtract m by n, but this gives us a negative exponent, negative value exponent. This will be captured by one of the laws of exponents later, but generally this is already what is the content of the proving of the division law or the quotient rule. As for this, let's wait for the video for that. So this is about properties, laws, and theorems. Please subscribe now.